Hello, good day, geometry. What's geoma hoppin'? In PO23, we talked about triangle congruency, and we looked at some triangles that are congruent, and we talked about what that is, corresponding parts, like up to the top here. So basically, congruent triangles are triangles that are the same size, the same shape, obviously triangles, and all of their corresponding parts have the same measure, okay? Which means that the three sides of one triangle are congruent to the corresponding sides of the other triangle, and the three angles of one triangle are congruent to the corresponding angles of the other triangle. So the two triangles that we have here are examples, or an example of congruent triangles, right? Because you've got essentially 6 parts here. You've got one side, a second side, a third side, right? So the 3 sides of one triangle are congruent to the corresponding sides of the other one. And then you've got 3 angles. One there, second corresponding there, and a third corresponding there. So for congruent triangles, there are really 6 parts that are all the same, the 3 sides and the 3 angles. Luckily, when we prove that triangles are congruent, we don't have to prove all 6. We only need 3 of the 6 to say that the triangles are congruent. Okay, so PO24, you'll see it's got a part 1 here. There are actually 4 parts to it. This first part that we'll go over tonight is kind of the postulates, the theorems, how we can prove triangles are congruent. I may do a proof or 2 just to kind of see it in action here. But then after this, the next 3 parts, parts 2, 3, and 4, are all proofs. Okay, actually using these. So today's a note day, so put your note writing wrist up, forwards, backwards, around and around. Get those exercises in so we don't get tired, and let's get to work. The first one is the side congruence postulates, or the SSS. Okay, so remember, I said we only need to get 3 of the 6 parts. One option is to get the 3 sides. So what this says, if 3 sides of one triangle are congruent to the corresponding sides of the other triangle, then the triangles are congruent. Okay, so if the 3 sides of one triangle are congruent to the corresponding sides of the other triangle, then the triangles are congruent. What that looks like, the side, got 2 triangles here. You would need to prove that the 3 pairs of corresponding sides are congruent. Okay? And you know those triangles are congruent because of the side congruence postulate. The side angle side congruence postulate, or SAS, is another option we have to prove that 2 triangles are congruent. And this one says, if 2 sides and the included angle, and that's an important distinction that I'll explain in just a little bit here, but if 2 sides and the included angle of one triangle congruent to the corresponding sides and angle in the other triangle, then the triangles are congruent. And eventually I just, rather than write the word triangle, I'll just draw one, okay? But you'll know what I mean here. Right? So the side angle side, the SAS, says if two sides and the included angle of one triangle are congruent to the corresponding sides and angle in the other triangle, then the triangles are congruent. So let's look at again kind of what that is in picture form here. There are two triangles. Okay. When it says two sides and the included angle. So I need two sides here. I'm going to mark those first. And when it says included angle, it's talking about a very specific angle. It's talking about the angle that is formed by those two sides. So not the top one, right? Not the one on the right here. It's talking about this angle here. The one that is formed by the two sides, kind of the angle that's between the two sides we know are congruent. That's what it means by included angle. So this would be an example of side, angle, side. And if you can prove that the two sides, two corresponding pairs of sides, and the included angle are congruent, those three pieces are enough to say the two triangles themselves are congruent. Okay? I've told you about my friend Doug before, who went through all my stuff and every so once in a while changed one of my icons. So angle side angle, or ASA, should be a key point, just like all of the others, but he instead replaced it with an angle there. So thanks, Doug. Appreciate it. Think about you every single time. So angle side angle congruence postulate, or ASA, similar to side angle side, says that if two angles and the included side of one triangle are congruent to the corresponding angles, not sides this time, angles and side of another triangle, then the triangles are congruent. If two angles and the included side of one triangle are congruent to the corresponding angles and side of another triangle, then the triangles are congruent. So what this is yet another combination of three parts that we can use to prove that two triangles are congruent. We have side, side, side. We have side, angle, side. And here we have angle, side, angle. What this looks like. Connect my triangle. Okay. So in this case, angle, side, angle, we need two of the angles. So I'll mark those here. I'll say that one and this one. Okay. Now, similar to side angle side, in angle side angle, we need that included side. So we're looking for the side that is in between our two angles, or the side that is a part of both angles. And that, in this case, would be the bottom one here. Okay. So angle, side, angle. If we can prove that, then we know the two triangles are congruent. If these three parts are congruent, the other three corresponding parts have to be as well. The next one is the angle side, or the AAS congruence theorem. Angle side, another combination of three parts that we can use here. And this one says, if two angles and a third side, or sorry, not a third side, if two angles and a side of one triangle, I gotta stop making these look like fours. You can tell I didn't do my wrist exercises quite enough. I'm starting to lose it here. If two angles and a side of one triangle are congruent to the corresponding angles and side of another triangle, then the triangles are congruent. Okay, so it's really got kind of the same pieces as angle, side, angle, just in a different order. So if you're looking at this and you're saying, oh, so really it doesn't matter if I have the included side or not, all I really need are two angles and one side, well, you're kind of right. It's just that if that side is the included side, you're using ASA, angle, side, angle. If that side's not included, you're using angle, angle, side, which seems like a minor difference, but again, when you're writing a proof, you've got to be very, very specific, okay? And if you prove a triangle is congruent using two angles and a side, that's not included, but you write ASA instead of AAS, you're wrong, okay? So, but what this looks like here, you need two angles. This time we'll do this one. There's one angle. That one, there's a second angle, okay? And an angle, angle, side, you just need one of the two non-included sides. So I chose the top left one, could have been the bottom one instead, okay? So long as it's not included. If it had been in the included side, then we're talking about ASA, okay? But here is angle, angle, side. And you're probably wondering, hoping, maybe even praying, say, please, let there be an angle, side, side theorem. There's got to be, right? Angle, side, side. Math is cool, okay? Well, it turns out there is an angle, side, side theorem. But because math is indeed G-rated, we don't call it the angle, side, side theorem. We call it hypotenuse leg, or HL, because the angle, side, side combination only works with right triangles, okay? And so therefore we can kind of bypass and call it the hypotenuse leg, or HL, because it only works with right triangles, and right triangles are the only ones with a hypotenuse, okay? So what this says, the HL Congruence Theorem, says that in right triangles, if the hypotenuse and one leg are congruent to the hypotenuse and corresponding leg, then the triangles are congruent, okay? So the last combination that we have here is the HL, hypotenuse leg theorem, and it only works with right triangles. So let me draw a right triangle here. And there's one. Try and make one that looks kind of congruent to it, okay? What this is saying here is that since it's right triangles, we already know they have one congruent angle, right? Because by definition, if they're right triangles, they have to have a 90-degree angle, which is going to be congruent, okay? That's one of the three pieces that we need there. So if the hypotenuse, which is that side opposite the right angle, and one of the legs, we'll pick the bottom one here, okay, are congruent, then the triangles are congruent themselves. Okay, so you can see that angle side relationship there, but because we don't want to call it that, since it's with right triangles only, we use HL instead, hypotenuse and the leg. Whew! All right, so there you have it. All the different combinations of things that we can use, parts of the triangles that we can use to say that two triangles are congruent. And I just want to go over one proof here. I think this video is getting a little bit on the longer side. So just looking at part 2, just the first one here, okay? Right? Time for some proofs. It says, given GH is congruent to JK, HJ is congruent to KG, and we need to prove that triangle GHJ, which is this triangle here, GHJ, is congruent to triangle JKG, which is this triangle here, JKG. Right? Okay, so that's our goal there, is to prove that those two triangles are congruent. And we're going to remember that we don't have to prove all 6 corresponding parts are congruent. We've got to choose either side, 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 angle, side, angle, side, angle, 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 side, and HL. And remembering that we need one of those 5 combinations of 3 corresponding parts can really help us narrow down and figure out what plan we're going to use for these 2 triangles. Because look at our given statement. What do I have? I've got a side congruent to a side and a side congruent to a side. I've got no markings of angles anywhere in the picture, right? I've got no information about angles anywhere in my given statement. I don't think I want to be using any of the combinations that involve angles. I don't even know for sure if these are right triangles. It's not marked, it's not given, so I'm not going to be using HL either, which means I'm kind of locked into side, side, side. And once I realize that, and I realize that, oh, hey, my given statement here, here's my 2-column proof, statement reason. I'm going to get that cursor out of there. It's thrown off my, whoa, not over there. Put it over here. There we go. Does that work? No, now it's over there. We'll put it down there. Okay. My given statement, I'm told that side GH is congruent to side JK. I'm also told that side HJ is congruent to side KG. And they're marked here also, right? GH is right there. That's marked congruent to side JK. And then HJ right here is marked congruent to side KG. Well, if I'm keeping track of my corresponding parts here, there's one side, there's a second side. I only need to find or prove that my third side, my third corresponding side, is congruent, and I've got my side, 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 right? So then I look at this and I say, okay, the third side of each of these triangles here is this side that they share down the middle there. And remember earlier when we were talking about all the different properties, transitive, symmetric, reflexive, I had you star reflexive, because even though we didn't really use it back in PO16, it comes up really big in triangles. Because if I'm trying to prove that this third side is congruent, well, notice that it's the same side, right? Those 2 triangles share that third side. So my second step is simply going to be JG is congruent to GJ. Now, why did I write those letters like that? You know, JG congruent to GJ. Well, remember, we have to, this order in corresponding parts matters, right? If I'm starting at point J, which is between my 1 and 2 marked angles and going up to G, on the other triangle, I have to start at point G, which is between my 1 and 2 marked angles, and go down to J. That's kind of a technicality there. It's an important one, but I'm not going to dwell on it now. The point that I want you to see here is that because of the, I forgot to mark my reason. It's the easiest one, given. But because of the reflexive property, okay, saying that something is congruent to itself, when we first wrote that down, I was like, well, yeah, duh, of course it is. Here's an example of it, okay? The third side of one triangle is the same as the third side of the other triangle, therefore they are congruent because they're the same thing. And lo and behold, there's my third part, which happens to be a side. So step 3 here, my proving statement, triangle GHJ is congruent to triangle JKG because of side, side, side. And I'm done. Okay? So that's kind of what the proofs are going to look like here in PO24, is you're going to be looking for what combination of corresponding parts, side, 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 angle, 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 side, or HL, can we use to prove the triangles are congruent. That's the lesson for today. There is going to be a Google quiz, so please hop over and complete that. Do retake it until you get 100%. Tomorrow we'll go over some more of these proofs, and I'll give you a couple to do over the weekend because I have every intention of being back here on Monday. Please, please, please let me back here on Monday. So, and then the test in this unit, unit 3, you'll either stay after school Thursday the 17th or Friday the 18th. It's up to you. If you're leaving for out of town on the 18th, you won't be here on the 18th. Obviously, come on the 17th, okay? But it's up to you. Either day is fine. So, homework, hop over to Google Quiz, take the quiz until you get 100%. That is how you math. Do not forget to like and subscribe, and have a great night.